All right, let's talk about factoring by grouping again. So remember, we're going to factor by grouping when we have 4 terms. So you can see this example. We've got 1, 2, 3, 4 terms, okay? And we need to make sure, really, step 1 is always factor out your GCF if there is one. And then you're going to factor out the GCF of the first 2 terms. And then you're going to factor out the GCF of the second 2 terms. And the thing, or the one that ends up inside parentheses, is one factor. And whatever ends up outside is another factor. Here's the thing with these, though. We might have to keep factoring if necessary. So that means that whatever we get in our parentheses, if we can continue to factor it, then we're going to have to go ahead and do that. Okay, so let's look at the example. So step 1, or pre-step up here, factor out the GCF. Is there a GCF between all 4 terms? There is not. So let's factor out. We're going to factor out by grouping. So we're splitting this up into 2. Factor out the GCF here, so our greatest common factor. So I'm going to go ahead and write out our factors here just so that we can see it visually. So x to the third is x, x, x. And x squared is x, x. So they share this x and this x, and this one and this one. So then our greatest common factor between our x to the third and x squared is x squared. So remember, we take that out, and in parentheses we have what's left. So if we take out 2 of the x's, we're just left with an x minus, well, we took out both of the x's, so we're left with 1. Okay, I'm going to factor out our GCF here. Remember, if this is an addition or a subtraction, that's what goes there. If it was a minus, we would put the minus there. So what is our greatest common factor between 9x and 9? Well, our factors are 9 and x, and our factors here, well, really, this is 3 and 3, right? Okay, let's try that again. So our factors here are 3 times x, and our factors here are 3 times 3. So they share this 3, and they share this 3, and 3 times 3 is 9. So our biggest common factor is 9. When I pull that 9 out, I'm left with that x. When I pull that 9 out, I'm left with that 1. Okay, so we said inside is one of our factors. So inside the parentheses is one of our factors. And then the outside, what's out here, x squared plus 9, is another factor. So this is where this 5th step comes into play. This is factored as much as it can be. But if we've got some x squared, x cubed, x whatever, more than just x to the 1, then we need to see if we can keep factoring it. And that's where one of these might come into play, our difference of squares, difference of cubes, and sum of cubes. Well, we have a squared, but it's not minus, so we do not have a difference of cubes. So we cannot factor this any further. This is our answer. Okay, let's do another example. Let's look at we've got 1, 2, 3, 4 terms. So we're going to factor by grouping. First step, factor out GCF if there is one. We've got x to the 4th plus 5x to the 3rd minus 4x squared minus 20x. Do you see what we have in common? We have an x in each of these, so I can go ahead and factor that x out. Take one x out. So when I take one x out of x to the 4th, I'm left with x to the 3rd. when I take 1x out, I'm left with 5x squared minus 4x minus 20. Okay, so this is going to be part of our answer, and we're going to let it hang out front while we factor by grouping what's inside here. So we're splitting this up. We're going to factor out our GCF here. So some of you can already see what the GCF is going to be, but I'm going to go ahead and write it out here to the side. So we've got x to the third, that's 3 x's. And we've got 5, only factors of 5 are 1 and 5, times x times x. So what do they have in common? They don't both have a 5, so that's not common. They've got an x here and an x here. So x squared, so write this out front. Let's make this a big old bracket so I can do mine. So we've got x squared is our common factor. And when I take away x squared from the thirds, I'm left with x on the inside. And when I take out that x squared from the 5x squared, I'm left with 5. Okay. Remember that sign travels down here, and I'm looking at the common factor between these two. So factors of 4 are 2 and 2 times x. The factors of 20 are 2 times 2 times 2 times 5. So what do we got in common? We got this 2 and this 2 and this 2 and this 2. So 2 times 2 is 4. And when I take out that 4, I'm left with x. And when I take out that 4, I am left with 10. 10. No. That's a 5. It's 4 times 5. I don't know why I did that extra 2 there. Sorry. Okay. I don't even know what I was thinking. All right. It wasn't. Okay, let's see what we got here. We got this x hanging out front. We got x plus 5 on the inside. X squared minus 4 on the outside. Step 5. Keep factoring if necessary. This is factored as far as possible. This is factored as far as possible. But can we factor this? So let's put on paper. Can we go back to difference of squares, difference of cubes, sum of cubes? We've got a squared and we have a minus sign. So let's see if we can do difference of cubes. So remember, difference of cubes, we're putting it into a plus b times a minus b. So we've got to take the square root of x squared to give me a. So a equals x. And we've got to get the square root of this number to get b. So b equals 2. So our difference of squares works because they're both perfect squares. So we've got x times x plus 5 times x plus 2, x minus 2. This is finally your answer. All right, let me know if you have any questions on factoring by grouping.